Hello, in this video let's discuss fourth question of today's contest. You are given 2D integer points where points of I is the ith point on the Cartesian plane. The Manhattan distance between the 2 points is mod of difference in x coordinates plus mod of difference between y coordinates. Split the n points into 2 groups exactly. The partition factor is the minimum Manhattan distance among all the unordered pairs of points that lie in the same group. Return the maximum possible partition factor over all the valid splits. So we have to return the maximum Manhattan distance that is possible if we divide this into 2 groups, where in each group we have to select the minimum Manhattan distance between any 2 pairs. N is up to 500, the coordinates are up to 18. For example, let's take the first example, 0, 0, this is a square. So we can group 0, 0 and 2, 2 in the single group, and we can group 0, 2 and 2, 0 in other group. So the distance between both is 4. So this is the maximum, like this is the minimum we can get. This is the maximum we can get, where it is simply the minimum of both minimums. So divide into 2 groups such that the minimum distance is maximum. Many things will come into our mind: bipartite graph, binary search, and so on. So let's just forget those and let's build intuition how to get. So let's take an example. For example, these are the 4 given points. So this is A, this is B, this is C, and this is D. So A, B, C, D. So what is the first thing that we can conclude? For example, I am taking a decision that I have to merge these two in a single group. So let's assume these two are in a single group, and the other possibilities make like don't group this into single group. So first is both A and B are in a single group, and the second thing is A and B should not be single group. So which option is better? This is better or this is better? Obviously second one is better. Why? Because the distance between A and B is very small. So if we decrease this, the answer also will be reduced. But we want as maximum answer as possible. So if we take very near minimum, like if we take very near point in a single group, then it will obviously decrease our answer. So this is better than this one. So now what we got? Now we got that it is better to start with the less distance, because if we try to group these both, then our answer will reduce. If they are in different group, then answer might have been increased. But if these two are in a single group, this is the worst choice for sure, because they're very near. So why are we trying to make this into a group? So why not any other point? So it is better if we take these two in a single group or these two in a single group. But these two in a single group is a very bad decision, because they are very near. So we don't want that. We want maximum answer as possible. So if the nodes are like if the pairs are very near, we have to make sure, like we have to try to make these two in different group. If this is not possible, then we can't do anything. But first we have to try to make sure that these two are in different groups. Why? Because if they are in the same group, then the answer will be reduced, but we want as maximum answer as possible. So now the main goal is to track the pairs which are very near, because that what decides our answer. So we have to track those. So now our main goal is to make sure that the nearest nodes, nearest pairs must be in different groups. So how can you do that? How can you track that? So in these problems generally there are, let's assume that we have n pairs. So we can assume that first pair in the first group. So first pair in the first group A. So if we assume that, then start from the second one. So go to second pair. So check whether this can be in A or B. So if this can be paired with one, then simply make this to a single group. Else make in the other group. And come to third one. So check third one whether it can be added in the first group or second group. So check these both and add this to the group where our answer will be increased. But here it is not the case, because it is very unclear, because we are not comparing here anything. We are not comparing two groups. We are just finding which two groups. So this is not the good idea. So we have to improve how we have to think. So making the first pair as first group and thinking other based on the conditions is bad. Now how can we track the nodes? How can we track the pairs with near distance? Let's say we have 1 and 1, 2, 2, and 0, 0, and 0, 1. Let's say we have these 4 nodes, these 4 pairs. So what are the two pairs which are very near? So these two. So firstly we have to make sure that we are observing this, because that's what decides the answer. So this this is 0, this is 1, this is 2, and this is 3. So now 2, 3 are very near. So we can maintain something like 1, 2, 3. So the distance between 2, 3 is 1, which is the minimum. So distance 1, 2, 3 is a pair. And let's check these two. So these two are also same. The distance is 1. So the distance is 1 and 0, 3. So 0th pair and 3rd pair are at distance 1. And now coming to these two. These are at 2. So 0 and 1 are different distance 2. So we can try to maintain something like this, so that at any time we can try to get the pair with the least distance possible. So why we are checking based on distance? Because if the pairs which are very near are in the same group, that decreases our answer. So we are making sure that we will try to make these in different groups. If that is not possible, then we can't do anything, but we have to try to make these in different groups. So but we can't find the distance between every two. Can we find that? Yes, because the number of nodes is only up to 500. So by n square, we can get all the distances between every possible pair. If n is 185, then we cannot do. But n is 500 here, so we can very simply use n square loop and get the distance between every two nodes, every two pairs. So if these are the 4 points, then we can get a, b, b, c are at distance 1, b, d at distance 2, and so on, because we can find in n square loop. And then so we got the distances. So we can store in something like pair of integer comma pair, because the distance and the coordinate is not the coordinate, but this is the first coordinate, this is second coordinate, something like this. So for example, if we have n pairs, so if we have n pairs, then we can try to make this as 0, 1, 2, and so on. Then we can try to maintain this one, because we don't need the coordinate, right? We don't need what is the coordinate, we only want the distances. But distance is already taken care of, because we are already traversing the loop, and then we are making based on the distance. So distance is already done. So now we only want what are the pairs which have this difference, which have this distance. So simply some mapping like this is sufficient. So 0th pair 0, first pair 1, and then in the distance pair we can store 0, 1. It means that 0th coordinate and first coordinate, first pair x, y are at distance 1, something like this. So now we got all the pairs and the distances. So we have to sort based on the distance, because we want to observe the pairs which are very near. So sort something like this. So after sorting, the one distance will be very first, then two distance, then three distance, then four distance, and so on. And what are these? These are simply the zeroth pair, first pair. What is zeroth pair? It is x0 comma y0, which is given, and one is x1 comma y1. So we are making something like this. And now let's say we are at distance 4. So we sorted this, and now let's start thinking about distances. Let's assume that we are traversing all this, and at a point of time we are at distance 4. So why we done this? We done this because we will start from the first. So we will start from 0, 1. So when we are at 0, 1, we will try to make sure that these two will go to different groups. These two will not be in same groups, because we discussed that if they are in same groups, our answer will decrease. So we are at 0, 1. So now our main goal is to only make sure that 0 and 1 are in opposite groups. So we'll make sure for 1, 2 also, we'll make sure for 0, 2 also. If that is not possible, we will do something, but we have to try that, right? So let's assume this worked here, this worked, and we came here also, but this is not possible. Let's assume that when we traversed all this, it means that we already made sure that every pair 0, 1 is in opposite group, 1, 2 is in opposite group, 0, 2 in opposite group, and we made all the conditions satisfied. And now let's say we are at distance 4. So we are at distance 4, and we are trying to check 0, 3 coordinate. But what if 0, 3 are already in the same group by above conditions? Because we traversed all distance 1, we traversed all distance 2, and we stored something to say that which two are in same groups or not. So but by that, if we get that 0, 3 are in same group, then we can't do anything, because why we are traversing this? We are traversing this to make these in different groups. But here, based on things we done in the above distances, we can't make sure that 0, 3 in opposite groups, because 0, 3 are already in same group. So what we should do if we are at some point like this, because we are trying, but we are unable to get it. So what we should do? that means that that is the answer. How is that? Let's say we are at distance 1. We done all the operations and we are able to make sure that every pair which is at distance 1 is able to satisfy the condition. What is the condition? They are in different groups. So all the pairs which are at distant 1 from each other, we are able to make sure the condition. That is very good. So come to 2. We made sure for 2 also. We made for 3 also. Now we are at 4. So when we are at 4, we are unable to make this true. We tried very much, but we are unable to do that. So what we should do? So this is the answer. So why is that? Because it it failed for 4. So we are unable to make for 4. So if we are unable to make for 4, how can we make for 5? How can we make for 6? Right? Because it is monotonic. We can take some examples and get that it is monotonic. So if this is not possible for 4, then it is obviously not possible for 5. It is obviously not possible for 6. So simply break the loop because we are unable to do 4. So how can we do 5? So this is simply modification of binary search. So we are starting from the very less distance and we are checking for every distance whether we are able to make condition satisfied or not. If the condition we are unable to satisfy, that is the answer. Because 4 is the maximum answer, maximum distance where we are able to get our answer. At every answer, at every distance greater than this, we are unable to do. So the answer is 4. So now our main goal. So hope you understand. If it is unable for 4, how it is possible for 5? So simply break the loop and return 4. Because this is the maximum distance that is satisfying our condition. So now what is our main goal? So our main goal is to find the distance where two pairs are already in the same group. So what does it mean? So let's say we are at 0, 1, we are at 0, 2, and we are at 1, 2. Let's assume these two. These are at distance 2, these are at distance 2, and this is at distance 4. So now we are traversing 0, 1. So we are trying to make these a different. So how can we make different? Let's assume 0 is in the A group, 1 is in the B group. Because these two are different, let's assume this is the configuration. And now coming to this. So coming to 0 and 2. So we have to make sure that these two are in different groups. 2 is not in any group. So 0 is in A. So we can add B in 2. We can add 2 in B. So this is also, we made sure this also. So after this, when we reach it here, 0, 1 are different, 0, 2 are different. And now coming to this. So coming to 1, 2, 1, 2 are already in the same group. So we can't do anything because they're already in the same group. So simply return 4. So now what is the main goal? Our main goal is to find the distance where two pairs are already in the same group. Here this is the possibility. Like here is the case. So we will return 4. And now how can we make sure? So how can we get the answer? So we got what to find, but how to find that? So from this example, we can simply think that we can maintain two sets. Set A consists of all the nodes, all the numbers which are in group A, and set B consists of all the nodes which are in set B. So can we simply do by this? It is not as simple as this. Why? Because it will take time. Because by using sets we can get TLE. So we'll discuss this in the after try run. But it is not possible for very big examples. So now how can we find that? The main thing here is we can't change things dynamically. So this will lead to TLE. So what is the other possible option to find this? So we want something like this to get an off one so that we can find our answer. So what are those conditions? We want some smart way that can be accessible on off one. What are those conditions? The first thing is we want whether two numbers are in same group or not. So we have to find whether two numbers are in same group or not. So for example, let's say here, so we are at this example, and if we give 1, 2, we have to get whether 1, 2 are in same group or different group in off one. So we want that functionality, and also we want other functionality. What is it? For example, let's say we are at 0. So this is the first distance. This is 0. So after this condition, we have to make sure that we store the information that 0 and 1 are in different groups. Else, how can we make sure that 0, 1 are in different group? So after processing this query, we have to store something like 0 and 1 are in opposite groups. So how can we store that? So now we can think in terms of graph. Why graph? Because let's say we are at 0, 1. So if we are trying to add edge between 0 and 1, let's assume that they are in different groups. So if we are at 0, 1, if we try to merge 0 and 1, if we try to add an edge between 0 and 1, that means they are opposite groups. So now it became simple. So initially it is 0, 1 and it is 1, 2 and then it is 0, 2. So now let's say we added 1, 2. We added edge between 0 and 1. So what does this mean? It means that 0, 1 are in different groups, not the same groups, right? Because this is the least distance. So our main goal is to make sure that these two are in different groups. So after making an edge between 0 and 1, this means that 0 is in A, 1 is in B, or 0 is in B and 1 is in A. So this is what it means. And then we came for 1, 2. So again, 1 is B. So we'll try to merge, add these two, and this is A. So now 0 and 2. So now we want a smart way to find whether 0 and 2 are in same group or not. We can simply do DFS or BFS, but that will take often. So that is not good. So what can be done? So the answer is DSU, Disjoint Set Union. So I already made a playlist on DSU. It is very useful in these kind of conditions. So given two nodes, we have to find whether these two are in same group or not. In OF 1, how can we make sure that we can find this? So let's say we added 0, 1, we added 1, 2, we added 2, 3. And there is also other component which is 4, 5 and 5, 6. So now the query is 3 and 6. So if the query is 3 and 6, we have to find whether these two are connected or not. So how can we find they are connected or not? So what if there is something like ultimate parent of component of node 3 and ultimate parent of component which is consisting of 6? So if there is every unique value, for every component, then we can simply check whether they both are equal or not. If they both are equal, it means they are in the same component because it is unique for every component. So for example, let's say we have 0, 1, 2, 3. Let's assume the unique hash value for 0, 1, 2, 3 is x and the unique hash value for 4, 5, 6 is y. So if we have something like this for every component, then if we have 3 and 6, so we'll find what is the hash for 3 that is already stored, which is x, and we'll find for 6 which is already there, which is y. So x and y are not equal. This means that they are in different component. So the main goal for DSU is to maintain unique value for every component. So we'll have something like x and y, and when we get a new query 3 and 6, we can check both of these in of 1 and we can return true if both are equal. If they are not equal, it means they are not in the same group because the value which you are storing is unique with respect to every group. Two different components cannot have same value. So that is the main goal. That is the main idea. And what can be that unique value? The unique value can be simply the ultimate parent node. So in two different components, a single node cannot exist. So that can be correct hash value. So when we are, so for 0, 1, 2, 3 component, the ultimate value is 0, and for 4, 5, 6, the ultimate value is 4. So now when we have 6, so this is parent. So what is the ultimate parent of this component? So ultimate parent of this component is simply parent of this. So 6 will ask this what is the ultimate parent, and this will ask this what is the ultimate parent. And now when coming to 4, the 4 is already ultimate parent of that, so simply return 4. So ultimate parent of 6 is 4. So this can be understood very simply by DSU. So check out my DSU playlist and then come to this point. So now we got why we are using DSU, and now how to track whether they are in same group or not. So let's check that also. That is the most tricky part. So let's say we have these points. So initially all are in different groups. So 0 is in other component, 1 is in other, 2 is in other, and so on. And now let's start merging this. So we got 0, 1. So 0, 1 are in different components. So simply merge these both. So after first query, we got 0 and 1. So let's assume 0 is A and 1 is B. And now these two are connected by edge. So this means that they are in different group. And now come to 2, 3. So now coming to 2, 3, this is the same case because they are in different component. So let's assume this is A, this is B. We can assume this is B or this is A also. But the only main thing is these both must be opposite because they are connected by edge. So if this is X, this is 1 minus X. If this is A, this must be B. If this is B, this must be A. And now coming to 2, 3. So we added edge between 2, 3 also. this means that they are in different component. And now coming to 3 4, so they are also in different component, so simply add between like this. So this is B, so this must be A. And now come to 4 5, so 4 5 is also very similar, so 4 5 this is B. So now all are completed. So let's come to next one, 0 and 5. So 0 and 5, so these two are also in different components, right? Because ultimate parent of 0 is 0, the ultimate parent of 5 is 2, so we can merge these two also. But now we have some big components, we have this big component, this big component. So if we are merging this both, what does this mean? This means that in the next queries we should add edge between 0 and 2, right? Because we are merging 0 and 5, like we are merging 0 and 5, this means that we are merging ultimate parent of 0, ultimate parent of 5, which is 2. So simply we are adding edge between 0 and 2. So that is what merging means. But this is also A and this is also A. This is contradictory, because if we are adding edge, they must be different. So now how we are making sure that, how we'll check now, because these both are same. So now we can do one thing. What? We can try to change 2 as B, we can try to change 3 as A, we can try to change 4 as B, and then we can try to change 5 as A. So if we change all these, then this is correct, because these two are connected. Now A and B are different. The condition is already satisfied in this component, and it is already satisfied in this component also. The condition failed only for these two, because these are in different components, so we are unable to make these sure before reaching this query, because 0 2 did not come till now. If they came already, they both will already be in single group. But now when we are reaching 0 2, they are in different component. So for now, from starting to now, we are unable to link these two. That's why they are in different components. So now we got 0 2, so we have to merge 0 2. So after merging, we have to make sure that 0 2 are in different groups, because they are in different groups, so we can make sure, right? So how can we make sure? For example, this is AB and this is BA. So if this is the case, then if they both are different, so if this is A and this is B, if they are already different, it is very good, this is awesome, no need to do anything, just add edge between 0 2. And how to add edge between these two? Simply make parent of this is equal to this one, right? So that means that they both are connected. So simply adding edge is simply like the parent of ultimate parent of u. So PRU is parent of u, ultimate parent of u, is equal to parent of B. So this is simply adding edge between these. Why? Because parent of parent u. So parent of A is this one. Is this one. So now parent of A became this one. So in this way we are able to merge those both. Only if they are different. So if this is A, this is B, only then we are able to merge, right? So what if it is A and it is A? For example, let's say we have AB and let's say we have ABB. Let's say these two are different components, and now we got a query to add edge between these two. Edge between these two means we have to make those different, but they both are equal, so we can't do that. We can do that. When can we do that? We can do if we try to flip every node to different component, so then the condition will be satisfied, because we flipped A to B, we flipped B to A, we flipped B to A, and now we can merge these two, right? Because this is A and this is B, so this is very good. So if two nodes in different components, then we can make sure that they both are in different, like if we are able to, we can make those opposite. So if it is A and if it is A, then we can flip all the nodes in this component, so A will become B, and then we can combine these two. And if it is A and if it is B already, then it is awesome, then we can simply add edge between these two. So now we got, right? Hope you got this. And then, but the time complexity will increase, because let's say this is very big, and this is AB and this is A, and there are 200 nodes in this. So if that is the case, then we have to flip everything in this. So this is very bad, right? And for example, we can now think that we can do the operation in smaller group, but what if both have 200? Then that is very bad, because it will take extra O of n kind of complexity. So now we have to ignore this. So how can we make sure that we are able to change every value, but not by traversing every value. So what I'm saying is, so now we got a solution, but that is giving tail. So what is the solution? Let's say the ultimate, it is a of a pair of component, and ultimate is also a. So if this is the case, then we have to merge these both. So merging these both means we have to make this b, and we have to flip every node group in this component. So only then we are able to merge these both. So is there a way to do this in often, not in the often, by traversing each and every node and changing its group? Is there any way to get in often? So if we think, there is a way. So that is because, so other very simple thing is, let's say why we found the ultimate parent color. Let's say we have 0 1, right? We have 2 3, we have 4, and this is ABA, and this is AA, sorry, AB. So if this is the case, and now the query we got is 1 and 4, right? So when we are merging these two, why we are not just taking this and this? If they both are equal, then it is possible. If they are not equal, then we can flip whole the component, right? So this is also possible. But why we found the group for ultimate parent? Because this is relative to its parent. Why? Let's say we have ABA. So if they are A and B. So if this is A and B, then after some queries, this can become B and A. Because if we get a new query, we are flipping the whole component. So if at a present time this is A and this is B, after some time in future, this may become B and this can become A. So this B is not fixed for this node, and this A is not fixed for this node. This is just relative to its parent. So if this is B, it means that if the parent is A, it is B. If the parent is B, then I am A. So this is what, right? Because everything is relative. Because we don't know the real group, which is the group the person don't have. Because let's say we have 1 and 2, we are merging these two. So this can be A, this can be B, or this can be B and this can be A. We cannot surely say that this is in B or this is in A. This is just relative to its parent. So whenever we get a query to merge two nodes, we can't simply compare those both. If they both are equal, we can we can flip everything. If they both are not equal, it is very good, we can continue. It's not like that, because they are relative. So when we are comparing two, we have to compare with respect to its relative parent. Only then it is true. So now we are selecting with respect to ultimate parent, and now we want a smart way to to change the group of the ultimate parent node in off1. So how can you do that? It is not very simply the group of parent node. So what I'm saying is, let's say we have 1 2 and we have 2 3. So we have A and we have B and we have A. So this is 4 5. So this is A, this is B. So now these both are same color. These both are A. So we cannot remove this from set A, and we cannot add in B, because these two are in a single group. So this must be A. So we have to flip everything. So how can we make sure that we are doing it off one? So this is what we discussed. We should reverse in either component. So if they both are same, we have to flip. How can we skip that? So now let's check terminology. So now everything is with respect to parent, right? So with instead of a set, we have to store some other vector for the whole nodes. So for example, let's say odd of u. So we are storing another vector, odd of u. So if odd of u is 0, it means that this node and the ultimate parent are in the same group. And if it is 1, it means that they are in different group. So why we want this? We want this because we have to skip off and loop, where we are flipping every node group. So how odd of u, like how maintaining odd vector can improve our time complexity? Let's check that. So now u and v. So odd of u XOR odd of ultimate parent of u. because odd of u is with respect to its parent. So if odd of u is 0, it means that u and the ultimate parent u. So u and parent of u are in same group, right? So odd of u XOR odd of parent of u. If that is 0, it means that both are equal. So if they both are equal, they are in same group. So u is absolute group with respect to parent u. So if the ultimate parent is A, this is also A. If the ultimate parent is B, this is also B. So if they both are equal, this is what that means. And similarly for V. So odd of V XOR odd of parent of V. If this is 0, it means both are equal. So V and ultimate parent of V are in same group. If that is 1, V and ultimate parent of V are in different group. So hope you got this. And now we have to add an edge between U and U. We have to add edge between U and V. So now, is there any of one way we can simply make changes in odd and then reflect in our whole answer? There is a way. So let's check how can I do that. So after adding edge between u and v, these both must be different. That is the main thing, right? So if odd of u is 0 and odd of v is 0, it means that these both are 0. So XOR is 0. It means that u and v are in same group relatively, right? Let's say this is a, ultimate parent is a, and this is also a, and ultimate parent is b, this is also b. So this is what, right? So odd of u is 0 because this is 0 with respect to its parent. Odd of v is 0, it is 0 with respect to its parent, with respect to this parent. So what does this mean? So what this 0 0 means? 0 means a and a are same, 0 means b and b are same. So now we have to make sure that these two are different. These two must be different. So then, so if this is the case, this is good because they are all different. But what if you have something like AA and AA? So if you have something like this, then we can't merge directly. So we have to flip. So what can we do now? So we can simply check odd of u XOR odd of v. So if they both are equal, they are in same group with respect to their parents. Now we want u and v in opposite groups. So simply odd of ultimate parent of u is XOR of both and then XOR with respect to one. So let's say AA and BB, right? So this is 0 and this is 0. So this is the ultimate parent of u. This is u, ultimate parent of u. This is v and ultimate parent of v. So this is 0, this is 0. So this means these both are same. This is 0, this means these both are same. And now we have to merge these both. So after merging this, um, if odd of ultimate parent, so odd of this one is equal to 1 XOR 0. So if that is 1, it means that they are in different component, like they are in different group. So if it is 1, we already discussed, right? So odd is with respect to parent. So now we are ultimately merging parent of u and parent of v because they are in different components, and now we are merging. So after merging these both, then we have to change odd of parent of u with respect to the parent of v, because parent of v is the ultimate parent of u now, because we're adding edge between these both indirectly. So now odd of parent of u should be changed. Why? Because this parent is changing, right? So ultimate parent of parent u is changing. So obviously this should be changed, right? So what should be the new value? So new odd of parent u is simply 1 XOR of both. So why is that now? So in this example, a u and parent of u both are a and the XOR is 0. In the component b and b, and the XOR is 0. And now we are merging this parent of u and parent of v indirectly, right? So this is a and this is b. So this is this a and this is this b. So now these both are good, right? Because we have A and B, so there is no need to flip. So now the only thing we have to do is these both are different. So the odd of this must be 1. Odd of A must be 1 because the ultimate parent is B and this is A. So these are different, right? Because these both are A. This means the parent, ultimate parent, and these are same. But here, these both are different, right? These both are different. So odd of ultimate parent of u must be 1. This means that they both are opposite. So the only thing we have to do without traversing the whole component is we can change the ultimate parent of u. So we can change odd of parent of u is simply 1 XOR 1 XOR XOR of sorry 1 XOR odd of u and XOR of odd of v. So why is this? So from this example we got right. So if that is AA and if that is BB. So if that is A and that is BB, so the odd must be 1 because these two can be merged. So these two also can be merged very happily because XOR of this is 0, XOR of this is 0. So this can be 1. So what is this one? So 1 is simply 1 XOR 0 XOR 0. This can be taken by examples. So let's take other example. So let's say we have AB and we have AB. So now the XOR is 1. So now the XOR is 1, right? So the XOR is 1. So after, so we can't directly merge. So after merging, we have to change the odd also because you have to flip here because we can't directly add these both. So when we're adding these both, right? So when we're adding these both, we have to flip these in our mind, not in reality, right? So after flipping, we can flip these both, and then so this is 1 and this is also 1 because the things in single group will not change because some queries already decided that this should be like this component. So why inside will be changed? For example, if this is A and this is A, so even after merging with any component, these both will be same. Why these both will be changed? Both will be A or both will be B. So once they are fixed, we cannot change it. Once the fate is fixed, if they both are same, we cannot change it. Maybe both can be changed to B, but not A and B or B and A, right? So now, even now, these A and B. So these both are opposite. So even after flipping, they are B and A. So now we have to merge these both. So after flipping, this is very good, right? So B and A are opposite, so we can merge. So now, what will be the ultimate odd of the parent of u? That will be 1 only, right? Because even now they are both are different. So the odd must be 1. And what is that one? So 1 is simply 1 XOR 1 XOR 1. So the both will cancel and ultimately will be 1. So very smartly when we are merging two components, if we are merging u and v, we can find ultimate parent of u and ultimate parent of v, and then we have to merge these both. So when we can merge these both, after merging, we can change order of parent of u. And what is that new order of parent? It is simply 1 XOR order of v XOR order of v. Let's check other case also. So let's say we have AB and we have AA. So this is what you want, right? So this is 1 because these both are different, and this is A, this is 0. So these both are different. So now we have to merge. So now we have to merge these both, right? So when we are merging these both are different. So we have to make sure that we have to change these and then only we can merge. So we have to flip these internally. So this will become, so first will become B and A and then second will become A and A. So after this, then we can merge. And even now this will satisfy. So odd of ultimate parent of u is simply 1 XOR of u and XOR of v. So after this, we can get the ultimate thing, right? Because we are able to merge these both in of 1. So this is what we want. Take more examples and then we can understand. So now we discussed if they both are in different group, right? So because till now the main discussion is what if they both are in different group, but what if they are already in same group? This is very simple, right? So let's say this is A, this is B, and this is B. So now we got a query of 1 2. So if we got query of 1 2, then how can we check? So odd of 1 will store with respect to 0. So odd of 1 is group with respect to 0. If this is 0, then it means that they both are same. If odd of 2 is with respect to group with respect to 0. So odd of 1 is group of 1 with respect to its parent, ultimate parent. and odd of 2 is also with respect to its ultimate parent, but they both are in same group. So now they both are mean with respect to same. So this is one, this is two. They so the same parent, right? This is same parent. So if this is A, like if the odd is 1 for this and odd is 1 for this, it means that they both are same, right? For example, let's say this is A and this is also A and this is also B. This is B. So the odd for the XOR for this is 0, the XOR for this is 1. It means that they both are opposite. So if the XOR are not equal, if the XOR is 0 and XOR is 1, it means that they are all in different group. So very good. So don't do anything. We can continue to next stage. But what if they both are same? If they both are same, then they both are in same group. So we discussed, right? We have to return the answer when we get an edge where both are in same group. So this is what we discussed. So if they both are in same group, so return the answer because they are already in same group. So this is very easy now. So if they both are equal, then continue. Like if they both are not equal, then continue. If they are in a single group, then return the answer. So now let's check the DSQ code, how to find the ultimate parent and how to merge the components. Let's say find a few. So how to find ultimate parent? Let's say we have a very big cube tree and we have to find ultimate parent for this node. So how can we check? So it is simply parent of u. This will ask its parent. What is parent? It will ask its parent. And this is the ultimate parent. So parent of that is parent of 3 is equal to 3 itself. So which means that we reach the ultimate parent. So if the parent of u is u, return u. Initially parent of u is u for every node. After merging, the parent will change. And how to find whether we reach ultimate parent node? So if the parent of u is that node itself, it means we reached the ultimate node. So parent of u is u, so simply return u. And now we have to change odd also, right? So odd of u. For example, let's say we are connecting these two. So if we are connecting these two, for example, this is A and this is A. Like there are some other edge. The ultimate parent is A, and this is also A, and now this must be B. So how can you make sure this must be B? So we have to add condition, right? So odd of this node is odd of this node XOR odd of parent node because this is with respect to parent. So simply odd of u XOR is equal to odd of parent, and then just store the parent also for future, so that there will be no time complex. Like we can store those, right? Instead of for every node, instead of going to parent node, we can simply store. So simply parent of u is equal to find of parent of u and return the parent of u. So find will return the ultimate parent and also it will store the group. It will update odd and I'll check the count. So now what the merge should do? The merge should return 1 if we are able to merge, and merge should return 0 if we are unable to merge. So what is the only condition when we are unable to merge? So for example, if we have query to merge these both in different components, we check that we can do this, right? So if this is A and this is B, then it is very good. If it is A and if it is A also, then we can flip in off one. So the only case where we cannot merge is if they both are in same component. So if they both are in same component, then simply return. So how can you check it? So find the ultimate parent of u, find the ultimate parent of v. So ultimate parent, ultimate parent. So if they both are equal, it means that they are in the same group. So if they both are equal, then return odd of u not equal to odd of v. Why? Because let's say odd of v is 1 and odd of v is 1. It means that they both are equal. We discussed. So if they both are equal, then we have to return 0 because we can't merge. So return 1 if they are not equal. Return 0 if they are equal. So return not equal to. So if they are not equal, it will return 1. This means that we can merge. If they are equal, we can't merge. And now merge the parents because this is parent u and this is parent v. So simply make parent of parent is equal to parent v. So parent of parent is equal to parent v. And then update the parent of u also. So out of parent u is out of u, XOR out of v, XOR 1. And then return 2. Because this is the only case where we can't merge. And for everything, when we reach it here, we can merge. So return 2. So this is the next part. So we store the edges with respect to distance and then start traversing. So traverse the all pairs which are a distant t. So initially j is equal to y. So just loop through every pair which are a distant t. If there is no possibility, then return that answer. So this is the distance. Like this is the distance. So this is the distance. and this is the Cartesian u comma w. There is a pair where u and w are distinguishable. So if you are unable to merge u and w, return D. If you are able to merge, then simply continue. Like simply go to the next one. If possible, next one. If not possible, return this one. And so simply we can do that. So hope you understand this. Let's check the code. It is very simple if you understand. So you have to return 0 and then store in edges, distance and the pair, and sort those based on the distance, and update parent of I is equal to I, out of I is 0, because initially all are in different components, so it is 0. And now this video already discussed, and in the merge we are able to find the parent which you already discussed. If you have any doubt, comment below. See you in the next video.